3 helium nuclei combine to form carbon. 2 carbon nuclei fuse to form magnesium. Magnesium to form neon, and so on over a period of hundreds of thousands of years, until silicon fused to form iron. Iron is a very special atom. The protons and neutrons inside its nucleus are very tightly bound together, so that even the extreme temperatures inside the stars couldn't get it to fuse into heavier elements. It resolutely stays iron. It was the end of the road. The production line of element building shut down. But our universe was still not complete. There were all the ingredients to make a glass of water, and some of the elements to build much of our convertible. There were also quite a few of the ingredients to make a human being. The oxygen we breathe, the calcium in our bones, and the iron in our blood. But there still weren't any of the vital ingredients like chromium for our car fender. And some metals like zinc that our bodies can't survive without. The universe was about to enter a super creative phase where it produces all the elements heavier than iron. To make the missing pieces in our birth of the universe jigsaw would take some of the most powerful explosions the universe has ever seen. Our universe has already celebrated its 500 millionth birthday. There are still another 13 billion more to go before humans appear on the face of the Earth. Giant new stars have made many of the elements in the world we see around us. But some vital elements are still missing. Heavy metals like chromium and zinc, and expensive ones like gold and platinum. To finish the job, the universe conjures up the most amazing phenomena since the Big Bang. Massive exploding stars called supernovas. When the giant stars that made the lighter elements ran out of fuel, they collapsed in on themselves, creating incredible amounts of energy and enormous explosions. These explosions were so powerful, they could fuse elements even heavier than iron and restart the element production line. Tony Metzacappa from Oak Ridge National Laboratory in Tennessee believes that without exploding stars, life itself would not exist.
Life as we know it certainly would not exist were it not for core collapse supernova events. They are very clearly one of the key links in our chain of origin from the Big Bang to the present day.
One of the most recent and biggest supernovas closest to our galaxy was seen in the southern hemisphere in 1987. When a supernova like 1987A explodes, it emits light containing the signatures of the elements within it. By examining this spectrum of light, scientists can calculate what elements are being forged inside the exploding star.
Massive stars, they evolve to an onion-like configuration at the end of their lives. They have an iron core, and outside of the iron core are layers of successively lighter elements.
Inside the iron core, the temperature rises to 8 billion degrees, nearly 300 times hotter than the center of the sun. It is so hot that the iron atoms that have sunk to the star's core are torn apart. The core destabilizes.
The cores then collapse on themselves in a fraction of a second. The collapse proceeds to very, very high densities.
The core collapses at speeds of more than 43,000 miles per second. A volume the size of the Earth crunches down nearly 6 times the size of Manhattan in an instant. The core becomes super dense.
If one were to take 1 cubic centimeter of that matter, that would be the size of a sugar cube. That sugar cube would be so dense that it would weigh as much as the entire human race.
The core rebounds like a compressed rubber ball and launches a massive shockwave. The shockwave hurtles out, smashing through the different skins of the star. As it punches through the outer layers of the star, The energy generated restarts the element production line. Atoms are smashed together to make brand new, heavier elements, all heavier than iron. Then the star explodes, and the shock wave pushes the shrapnel-like debris outward, further and further into space.
In a very real sense, our lives depend on the stars in the universe. Without their lives and deaths, we would not be here today.
These astonishing images taken by the Hubble Space Telescope show the aftermath of these giant explosions. Nebulae, giant clouds of debris thrown off by exploding stars. Swirling inside are big new atoms, gold, silver, zinc, and lead. Without supernovas, our world would be a very dull place, and possibly lifeless.